All right, welcome to The Explainer. Today, we're going to do something pretty cool. We're building a cloud application right from scratch. We're going to lay out the blueprint for an app that's not just secure and reliable, but one that's ready for some serious scale. And we'll be using the foundational building blocks of Microsoft Azure to do it.
And really, it all boils down to this one question. I mean, look, anyone can build an app, right? But can you build one that can handle the absolute chaos of the real world? How do you take just a little piece of code and turn it into a digital fortress? Well, let's dive in and find out.
Okay, first things first. Every single application out there, it doesn't matter how complicated it is, it needs a place to live. It needs a computer to run its code on. And in the cloud, that home is our absolute foundation.
And that home, we call it a virtual machine, or just a VM for short. The easiest way to think about it is like this. Microsoft has these huge, powerful physical servers humming away in their data centers. And there's this layer of software, a hypervisor, that sits on top and basically carves out these little private virtual computers just for you to rent. That's your VM. You get to pick the operating system, and you're in charge of everything that runs inside it.
Now, depending on the operating system you choose, and it's usually going to be Linux or Windows, that's going to decide how you actually connect to it. If you've got a Linux machine, you're using a command line called Secure Shell or SSH. But with a Windows machine, you get a full graphical desktop, and that's called Remote Desktop or RDP. Each one uses its own specific digital doorway or what we call a port. And let me tell you, securing these doorways, that's our absolute first line of defense.
Okay, so we've got our server. But just spinning up a VM and putting it online, that's like putting a house on a busy street and just leaving the front door wide open. Not a good idea. We need to build a secure, private, digital piece of land for our application to live on.
And that private property, that's what we call a virtual network, or VNet. I want you to think of it as your own isolated slice of the Azure cloud. It belongs to you, and only you. Literally nothing gets in and nothing gets out, unless you say so. This is how we draw that critical line in the sand between our application and the Wild West of the public internet.
And this VNet has a really logical structure. The VNet itself, that's like the main property line of your land. Then, inside that property, you can create subnets. Think of these as fenced-off areas to keep things organized. You might put your web servers in one fenced-off plot and your databases in another. And the thing that directs all the traffic between these little plots and out to the wider world, that's the job of the route table. It's basically the GPS for all your network's data.
All right, so we've got our private land, we've got our fenced-off plots, but we still need a bouncer at the gate, right? Someone who's checking IDs and deciding who gets in and who stays out.
And that bouncer, in the Azure world, is called a Network Security Group, or NSG. It's a really smart firewall that you can stick right onto your VMs or even an entire subnet. And what's cool is that it's stateful, which just means it's smart enough to remember who it's already talking to. It all works by going through a list of security rules that you get to write.
So here's how it works. The NSG looks at the rules based on priority, starting with the lowest number. So Rule 100 here says, okay, let's allow web traffic on port 80. Got it. Then Rule 110 says, and let's also allow secure SSH access so we can actually manage this thing. And then way down at the end, there's this catch-all rule that says, deny everything else. So if the traffic doesn't match one of our allow rules, boom, it's blocked. It's really simple, but incredibly powerful.
Okay, so now we have a new problem. It's a good problem, but it's still a problem. Our app is a massive hit. We're getting tons of traffic, and while that sounds great, it's actually a technical challenge that could bring our entire fortress crashing down.
And why is that? It's because a single virtual machine, well, it can only juggle so many requests at one time. If you flood it with users, it's going to get overwhelmed, it's going to slow to a crawl, and best case scenario, it crashes. Worst case, it takes your entire application offline with it.
So what's the solution? It's something called a load balancer. I want you to picture it as a super efficient traffic cop. Instead of just waving all the cars, all your users, down a single lane road to one server, it sits out front and directs traffic evenly across a whole bunch of identical servers. This makes sure no single machine ever gets totally swamped. And a load balancer is made up of a few key parts. First, you've got the front-end IP. That's the one single public address that all your users connect to. Then you have the back-end pool. That's just the group of all your VMs that are doing the actual work. Next, and this is super important, you have a health probe. This thing is constantly checking on your VMs, asking, hey, you still good? You still healthy? If a VM doesn't answer, the probe tells the load balancer, which immediately stops sending traffic its way. And finally, you have the load balancing rule, which is the brains of the operation. It's what connects that public IP to the healthy VMs in the pool.
But here's the thing. Traffic is unpredictable. You can't pay someone to sit there at 3 a.m. waiting for a sudden spike so they can frantically start adding more servers by hand. That's just not going to work. We need this to happen automatically.
And this right here, this is the key to what we call a truly elastic cloud application. So the question becomes, how do we make our app breathe? Expand when demand is high and then shrink back down when things get quiet?
The answer is a virtual machine scale set, or VMSS. You can think of it as a much smarter, more advanced version of that back-end pool we just talked about. It's a service that manages a whole group of identical VMs for you, and based on rules that you set up, it can automatically add more machines when things get busy. We call that scaling out. And just as importantly, it can remove them to save you money when things calm down. That's scaling in.
Let's walk through how this actually works. So you start by setting a baseline for your normal, everyday traffic. Let's just say that's 2 virtual machines chugging along in your scale set.
But then, your marketing team launches a huge campaign, and traffic just explodes. Your auto-scale rule, which is always watching, sees the average CPU usage across your VMs spike past the 75% limit you set, and then, bam! Instantly, the scale set kicks into gear. It spins up 8 brand new VMs, bringing our total to the maximum of 10 that we allowed. The load balancer immediately starts spreading the traffic across all of them, and the app stays lightning fast for every single user. And the best part? Nobody had to lift a finger.
And then, once the rush is over and the CPU usage drops back down, the scale set automatically starts removing those extra VMs, scaling right back into your baseline. You only paid for all that extra horsepower for the exact amount of time you needed it. That is the power of cloud elasticity.
And just like that, by layering these pieces together, we've gone from one single, fragile server to a really robust, self-healing, and super cost-efficient application architecture. So let's just recap the blueprint real quick. We started with a virtual machine to run our code. We locked it down inside a secure virtual network and subnet. We put a bouncer on the door with a network security group. We made sure it wouldn't fall over with a load balancer. And we gave it the ability to grow and shrink on its own with a virtual machine scale set. See? Each piece solves a very specific, critical problem.
Now this blueprint is incredibly powerful, but let's be real. Clicking through a web portal to build all this out every single time, that's not exactly efficient. So what if? What if you could define this entire thing in a single file of code and deploy it in minutes, over and over again, perfectly, every single time? Well, that is the world of infrastructure as code, and that's the next big step in your cloud journey.